The first section of chapter 3 deals with complex numbers. Complex numbers, we're going to define what those are and learn how to use them and how to solve equations. Section 2 deals with quadratic equations and functions. This is where we start. Now we're getting away from linear equations. Now we're getting to what are called polynomials. Section 3, we're going to analyze graphs of equations. 4, we're going to solve rational and radical equations. What are rational equations? The first 5 letters of rational spell what? Ratio. These are fractions. We're now going to look at equations with 2 or more fractions in them. Radical equations are the square roots, or cube roots, or fourth roots. Those are radicals. They look like this. And then we end up the chapter looking at solving equations with inequalities. Now, this won't be the same as last time where we just have a line, put a dot or parenthesis or bracket. When we deal with inequalities, so equations, we now have an X and a Y variable, which means we're now going to shade, let's pretend this is our graph. We're going to shade the entire region. We have to first find the inequality line, and then the answers above there or below there. And it's all of them above or below. So it's not just one section or one number, it's a whole region, series of numbers. All right, so let's begin. Copy this. This is what we're going to do today. Section 1. We're going to define complex numbers. We're going to learn how to find complex numbers. We're going to do the algebra of complex. Remember when I said, whenever you say algebra of complex numbers, all that means is add, subtract, multiply, and divide. We're going to learn how to do those with complex numbers. We'll worry about that when we get to it. I to the power n. And then we'll look at complex conjugates. We need this complex conjugates in order to be able to do division. So I'll introduce these when we do the division of the algebra functions. All right. So let's look at what are complex numbers. So far, if I give you a question like this, the answer would be what? 2. If I gave you a question like this, the answer would be what? Simplify this. Remember how you do it? What is 8 made up of? 4 times 2. 4 is made up of 2 times 2. So 8 is made up of 2 times 2 times 2. It's 2 cubed, yeah, but inside the square root, how many do we need to take it out? What number is inside there? What's the root? Yeah. Anything else other than 2, if it's a 3, 4, 5, there has to be a number there. This is called the root. If it's a third, fourth, fifth, sixth, seventh root, there has to be a number there. If there's no number there, it's an invisible 2. It's a square root. So when I say squared, x squared, 2. All right, so what this means, the root tells us how many of the same number do we need so we can take it out? 2. And we have 3 of them, so take these 2, they come out. Whatever's left stays inside the radical. Yes, only for like numbers, because the reason the square root of 4 is 2 is because 4 is made up of 2 times 2. Because they're the same number, I can take them out. Likewise, square root of square root of 72. Let's look at that one. Since this is a square root, we need 2 of a kind to take it out. So what times what is 72? Nine times 8, okay. 9 is made up of, that's as far as you can go. They're prime numbers now. 8 is made up of 4 times 2, but 4 can go further. So 72 is made up of 3 times 3 times 2 times 2 times 2. These are the, look at the end numbers. So far, so good. So we'll break it down to its prime numbers. It's called prime factorization. This is called. That's what I'm getting to. I'm building up to it. So since we broke down 72, so now if there's a pair of numbers, they can come out in front. There's a pair of numbers there. Whatever's left stays inside the radical. 3 times 2 is 6. Square root of 2. Okay, so that's how you simplify radicals. And that's what they mean, is you need to have 2 of a kind to take it out. But there's always a but. But what about solving this equation? Can't, well, -2 times -2 does not equal -4. 2 times 2 doesn't equal -4. So now we have a problem, because we cannot take a square root of a negative number. This is where imaginary numbers come in. The square root of -1. Let me work it out for you. Let me see, I'll show you where it came from. Whenever you see a square root of a -1, instead, since that can be done, we just replace it with an I. So this is the definition of an imaginary number. Anytime there's a negative inside a square root. So basically, if there's a negative inside a square root, remove that and just put an I in front. So that becomes an I. And I'll show you why in a second. I'm just showing a shortcut right now. And then once you remove the negative, you have square root of 4. So the answer is 2I. Square root of 4 is 2. So instead of having I2, it's common convention in mathematics, always put the number in front of a letter. It just looks nicer. The variables always follow the constant numbers, the coefficients. So let me show you exactly how all this transpired. All right, so we had y equals square root of -4. What is -4 made up of? Well, yeah, but we want to get rid of that negative. What it's really made up of is -1 times 4. Because we have to get rid of that negative. You're right, it is 2 times 2, but we want to get rid of that negative. Because they're multiplied, we can split these two equations up. There's a rule. If you have a product of two numbers inside the radical, then you take the product of each radical separately. And here's the proof of that. Yeah, we all know what square root of 36 is. Square root of 36 is 6. But 36 is made up of 4 times 9, right? So with our rule here, I can split them up. Square root of 4 times square root of 9. What is the square root of 4? Times the square root of 9 is 2 times 3 is 6. So that's what the property tells us is whenever you have a product inside a radical, you can split them up, which is what we did here, which is what we did there. So whenever you have a negative inside a radical, split them up. The -1 goes inside one radical and the number goes in the other. Square root of -1 equals what? I. That comes from this page right here. Whenever you see a square root of -1, that automatically equals I. Square root of 4 is 2. So the answer is 2I. Makes sense so far? Because yeah, we're building up to it. Yes. Right? Okay. So that's defining imaginary numbers. So the logical question is, so we haven't talked about complex numbers yet. Okay, complex numbers. Look like this. A plus BI. Inside here? Yeah. Whenever you have a negative inside a square root, an even root, if we had square root or cube root of -8, odd roots, you can have a negative answer. Remember the graph. If x is -8, the cube root of -8 is -2. So if it's odd, you can have positive or negative or 0. But if it's even, 2, 4, 6, 8, 10, 12, whatever, it can only be positive inside there. So we have to take out the negative. So basically the shortcut is whenever you have a negative, take out the negative and put an I in front of it. So what you could have done is just done that. So That's a shortcut, but this is mathematically what's going on. So far, so good. Now, every number is a complex number. Every number is a complex number. This, the A, is the real number. B is the imaginary number. That's a complex number. A complex number is made up of a real number and an imaginary number. Where A and B are integers. That's symbols. A and B are elements of the integers. So A and B are integers. What's an integer? An integer is anything from negative infinity to positive infinity. Number-wise, no decimals. -10, -5, -1, 0, 1, 5, 10. Those are integers. So, is that a complex number? 4 plus 3i. Is that a complex number? It's got a real, imaginary, it can be positive or negative. Is that a complex number? Think of this. We have A plus BI. So this is the real number, right? So that's a 2. What would, since there's no I, what is the value of B? Is that one of the integers? So this is a complex number. That's a complex number. Where here, A is 0 and B equals 3. So basically, when we look at complex numbers, we look at 2 possibilities here. If B equals 0 and if B does not equal 0. Remember, B is the imaginary coefficient. So we have A plus 0i, which is just A. And then here we have A plus BI. So that's what we have, that's what we're looking at. All right. So now let's look at some examples of finding complex numbers. How we in equations. We had one example up here already. Use the rule I just gave you the last page Whenever you multiply radicals, we use that rule there. So be very careful about this, though. How many of y'all are doing this so far? Okay, that's one way of doing it. I'll call that the wrong way. I'll show you why in a second. If you did this way, -3 times -5 becomes what? Negative times negative is a positive. So it's radical 15. So that's what you would come up that way. But aren't both of these imaginary numbers already? This one is actually I radical 3 times this one, which is I radical 5. So I times I is I squared. Radical 3 times radical 5. Are they the same thing? No. So whenever you have negatives inside the radical, take them out first with making imaginary. Make them imaginary first. And then from there, just multiply inside there. So the question I have of you, what does I equal? What's the formula for it? Very good. Radical -1. We had that from the bottom of this first page. I equals radical -1. But we have an I squared here. If I square both sides, what happens? What does the square do with this radical? Cancels it. So whenever you see an I squared, it becomes a -1. So in our equation, it becomes -1 times radical 15, which becomes negative radical 15. That's the final answer. So far, so good. I mean, there's a lot of different letters and words here, but that's what I said. Mathematics is a language. Once you understand the words and what they correspond to, the mechanics is pretty easy. It's just that we have to combine it all now and make it mathematical. Work that one out, please. Radical -6 times radical 8 times radical -2. So what does the first one become? Radical negative 6. I radical 6. The other one is just radical 8. The last one becomes, so far so good. We got rid of the negatives. I times I is I squared. Since these are all multiplied now, 6 is made up of what? 2 and 3. 8 is made up of 2 times 2 times 2. And then the last 2. So this is the 6, this is the 8, and this is the 2. So what can come out? Here's a pair of 2s. Here's a pair of 2s. And that's it from inside. 2 times 3 is 6. So I took these 2 out. What I'm left with is 2 times 3 is 6. So there's I squared in front, and both of these I took out. Two times 2 is 4. I squared makes it -1. So 4 times -1 is -4, radical 6. There's the answer. Shortcut, 4I squared, any number I squared, because we know that radical or I squared is -1. So all this really does is change the sign in front of its coefficient. All the I squared, this is -1, it changes the sign of its coefficient. That's all it does. That's a shortcut. So far, so good. Let's look at the algebra now. The algebra of complex numbers. Basically, there's one real rule. Combine like terms. That's the only real rule. So let's look at addition. We have 2 plus 3i in parentheses plus 5 plus 7i in parentheses. Order of operations still applies. What's the first thing you have to do? Inside the parentheses. Can we combine anything inside the parentheses? No. So if we can't do anything inside the parentheses, can we get rid of the parentheses? Is there any, are there any coefficients in front of the parentheses? There's nothing in front of there. So I could just drop the first parenthesis. There's a 1, so I'll multiply everything by 1. Same with the other. There's a positive 1. So it becomes a positive 5 plus 7i. So we got rid of the parentheses. Whenever you get rid of parentheses, the first step is always combine like terms. Combine the real numbers. 2 plus 5 is 7. 3i plus 7i is 10i. Three plus 7, they're both i's. 3 plus 7 is 10. There's your answer. How about this next one? Negative 3 plus 2i in parentheses plus 5 minus 6i in parentheses. Since there aren't any coefficients and they're all positive coefficients, we just drop the parentheses. So just get rid of those, just get rid of those. Combine like terms. Negative 3 plus 5. 5 is bigger, so the answer is positive. 5 minus 3 is 2. 2i minus 6i. 6 is bigger, so it's negative. 6 minus 2 is 4i. Now let's look at one that has coefficients in front of it. 2 times 3 plus 5i plus 5 times negative 2 minus 3i. First step. Can we do anything inside the parentheses? So we get rid of parentheses. How do we get rid of parentheses? Very good. What's that called? The process. You're right. Multiply by the coefficient. What's that process called? Distributivity. Because yeah, you're distributing the coefficient. 2 times 3, 6. Positive 2 times positive 5 is positive. 2 times 5 is 10. I. Positive 5. Positive times negative is a negative. 5 times 2 is 10. Positive times negative is a negative. 5 times 3 is 15. I. We get rid of the parentheses, so get rid of combine like terms. Positive 6 minus 10. 10 is bigger, so it's negative. 10 minus 6 is 4. That gets rid of those guys. 10i minus 15i. 15 is bigger, so it's negative. 15 minus 10 is 5. We've done this stuff before with x's. If you have x's in there, it's the same thing. Okay, that's addition. Subtraction is the same thing we've always done. Five plus 2i minus 8 minus 6i. What everybody finishes. The first parenthesis, I can just drop it. There's nothing, no coefficient. But the second parenthesis has this negative in front of it. So what it does, it's going to change all the signs inside there. Negative times positive is a negative. 1 times 8 is 8. Negative times negative is a positive. 1 times 6 is 6i. There's a 1 here. It's an invisible 1. Now combine like terms. They're opposite signs. 8 is bigger, so it's negative. 8 minus 5 is 3. 2 and 6, same signs. They're both positive. 2 plus 6 is 8i. So far, so good. We'll do one more of those. It looks weird. Are these all complex numbers? Yeah. So get rid of the parentheses. Negative times negative is a positive. 3 times 4 is 12. Negative times positive is a negative. 3 times 2 is 6i. Negative times negative is a positive. 6 times 3 is 18i. Combine like terms. There's only one real number, so it's 12. The i's, different signs, so take the sign of the larger, which is 18, so it's plus. 18 minus 6 is 12i. That's subtraction. Same as addition, just signs. Multiplication. 2 plus 3i, 3 plus 4i. So anybody guess what kind of method we're going to use here? It's going to be the same thing. It's going to be distributivity, because everything in this first parenthesis has to multiply to everything in the second. So we're distributing to it. But since these are both what are called binomials, we have two terms in each. They're called binomials. Anybody remember that? The FOIL method? You remember that? High school? Okay. FOIL method only works when you have two terms times two terms. Binomials times binomials. F stands for first. The first terms in each. 2 times 3 is 6. What does O stand for? Outer. So 2, they're both positive. 2 times 4 is positive 8. I. The I stands for inner. These are the inner ones. So they're both positive. 3 times 3 is 9. I. And the L stands for last. The 3 and the 4. 3i times 4i. They're both positive. The answer is positive. 3 times 4 is 12. I times I is I squared. So that's the FOIL technique. The first ones, the outer ones, inners, and the last ones. Note, it's very important that when you add and subtract terms, the only thing that changes is the coefficient. When you add and subtract, the only thing that changes is the coefficient. When you multiply, the coefficients and the exponents change. I times I is not I times I is I squared. Okay. What's next? Order of operations. Are there any special operations? There's a square. What does I squared equal? I squared is equal to -1. So positive 12 times -1 is -12. Once you become comfortable with that, this I squared simply changes that sign. The I squared simply, all it does is really change the sign in front of the coefficient. Change the -1 multiply. It's going to be the same thing. Now we combine like terms. 6 minus 12. 12 is bigger, so the answer is negative. 12 minus 6 is 6. The i's, 8 and 9, they're both positive, so the answer is positive. 8 plus 9 is 17. I. There's your answer. So that's how you multiply imaginary terms or complex numbers with a process called distributivity. Want to do another one? Let's do one more. Actually, a couple more. -3 minus 2i times 4 minus 5i. So using the FOIL method, first one's -3 times +4. So it's -3 times 4 is 12. That's the first term. The outer ones, negative times negative is a positive. 3 times 5 is 15i. There's one I. The inner ones, negative times positive is negative. 2 times 4 is 8i. The last ones, negative times negative is a positive. 2 times 5 is 10. I times I is I squared. So I squared just changes that sign in front of there. So it becomes, instead of +10, it becomes -10. -12 minus 10, they're both negatives, answer negative. 12 plus 10 is 22. 15 minus 8, 15 is bigger, so it's plus. 15 minus 8 is 7i. There's your answer. Getting better? Let's put two more up there to get more comfortable, but there's these next two I'll put up there will be interesting. The solutions will be interesting. 2 plus 3i, 2 minus 3i. Okay, so the first one. 2 times 2 is 4. Positive times negative is a negative. 2 times 3 is 6i. Positive times positive is positive. 2 times 3 is 6i. Positive times negative is negative. 3 times 3 is 9. I times I is I squared. Again, this I squared, all it really does is change the sign in front of the coefficient. So it's 4 minus 6i plus 6i plus 9. What happens to the 6 i's? Negative 6 plus 6, they zero out. Give me any two digits between 0 and between 1 and 9. 8 and 5. So 8 plus 5i, 8 minus 5i, is 89. But go ahead and work it out. What's that? Yeah, I was kind of hoping you were, but I'm glad you did these also, because you'll see that it's going to be, I'll show you a shortcut next. If you have to, you can take off your shoes and use those, your toes also. Just kidding. What's 8 times 8? 64. Positive times negative is negative. 8 times 5? 40i. They're both positive. 5 times 8 is 40i. Positive times negative is negative. 5 times 5 is 25. I times I is I squared. We see automatically that the 40s cancel. Let's get rid of those. They're the same but different signs. This I squared, all it does is change the sign in front of there. So what I have is 64 plus 25, which is 89. Yes. I squared becomes -1. So it disappears. And that's what we're going to learn in a little bit, that in an equation, in any polynomial equation, you can never have an exponent on I. If you have the imaginary number, the complex number is A plus BI, not I squared or I cubed or anything, it's I. So, and I'll show you how to get rid of any higher powers. All right, does anybody see the shortcut here? What I just did? Yep. Just forget the i's. Square both of those numbers, add them together. 2 squared is 4, 3 squared is 9, 9 plus 4 is 13. 8 squared is 64. 5 squared is 25. Is 89. But that only works in one type of equation. What do you notice about these two equations? Except, yeah, the same numbers. Only thing that's changed are these signs in the middle. Those have a name. Complex conjugates. Just change the sign in front of the imaginary term. The complex conjugate is simply the sign in front of the imaginary term has been changed. So if you had A plus BI, the complex conjugate is A minus BI. So all I do was change that sign. Everything else is the same. And if you ever see that, like you figured out earlier, when you have complex conjugates multiply to each other, all the answer is going to be is square the A plus square the B. No i's. All the i's are gone. Complex conjugates get rid of the imaginary term. Get rid of the imaginary term. That's the whole purpose we have complex conjugates for. But the question you should have is, why do we want to get rid of all the i's? Division. The only rule in division, you cannot have an imaginary term in the denominator. The bottom. Whenever you deal with fractions, with complex numbers, you cannot have an I on the bottom. So we have to get rid of it. This is how. If you have a monomial imaginary term on the bottom, multiply top and bottom by I. What's a monomial? Yeah, only one term. Yeah. So if we had this, only one term on the bottom. And the I is on the bottom. If the I is not on the bottom, you don't have to worry about it. But since there's an I on the bottom, we have to get rid of it. How do we get rid of it? Multiply the top and the bottom by I. What is I divided by I? Anything divided by itself is what? Yeah. 3 divided by 3 is 1. And that all I'm doing is multiplying by 1. So this becomes 3i over 4i squared. What does I squared do? Yeah, turns it into a negative. And common convention, we don't want i's on the bottom, so we put it on top. Okay, simplify that one. Is it too early for a trick question? You're done. You can't go any further. Only if the I is on the bottom. There's no I on the bottom, so you don't do anything. You're done. Trick question. See if you're listening. Okay, so that's with monomials. Oh, no, let's take another one. 2 plus 3i over 4i. Is there an I on the bottom? Yes. So if there's an I on the bottom, what do? Multiply top and bottom by I. Because it's a monomial. So I times 2 is 2i. Plus I times 3i is 3i squared over 4i squared. This I squared changes that sign, so minus 3. This I squared changes that to a negative 4. Everybody follow me so far? I don't hate lose anybody. So now we have a negative on the bottom. So we bring it up to each term on top. You never want to have a negative on the bottom. So the bottom is always going to be a positive number. So this negative changes everybody's sign up there. So it's negative 2i plus 3. Yeah, negative 2i plus 3 over 4 is not really wrong, but it's not really right. It looks ugly because complex numbers have to have real plus imaginary. So we just switch the top. 3 minus 2i, and there's your answer. Okay, now we have a binomial on the bottom. If you have a binomial, imaginary term on the bottom, multiply top and bottom by the conjugate of the denominator. So if you have a binomial on the bottom, notice we always look at the bottom. If it has imaginaries, always look at the bottom number. If it's a monomial, just multiply it by I, top and bottom. But if it's a binomial, it has two terms. Bi means two. Multiply by the conjugate. What's the conjugate? Remember how we find the conjugate? Yeah, we just change the sign between there. So it becomes 3 plus 4i, 3 plus 4i. Yeah, so always look at the bottom. And the conjugate is simply change that sign. Because 3 plus 4i over 3 plus 4i is 1. Now, FOIL. 2 times 3 is 6. 2 times 4 is 8i. 3i times 3 is 9i. 3 times 4 is 12. I times I is I squared. Nine plus 16. Remember, take this number, square it. Take this number, square it. So the bottom number is going to be 25, right? That I squared changes that sign to a negative. Six plus 8i plus 9i minus 12. Six minus 12. 12 is bigger, so it's negative 6. 8 plus 9 is 17. I over 25. What do you think so far? Yes, there are a lot of moving parts, but the moving parts are pretty straightforward. It's always the same rules. So again, have your set of rules on a sheet next to you when you're doing the homeworks. We're out of time today, but next time, we're going to solve equations like this. Nope. The answers can either only be one of three things: an I, a negative I, a 1, or a negative 1. Remember, your final answer, you can never have an exponent in I. It's either going to be I's or 1's. That's what the last part's going to be of this section. All right, so that does it for today. Any questions? Well, I'll cover this on Thursday, and then we'll start quadratic equations. Because yeah, now we're starting to build up different type. We're done with linear equations pretty much. Now we're going to start building up to quadratics, cubics, and higher order polynomials. Now comes the real math. Yeah, so much for the fun time. All right, everybody, have a great day. I will see you Thursday. Let me make sure I stop recording.